All right, so I talked a little bit too much before this lesson, so we only have 10 minutes left, but we can get a few things done. At least, yeah, I don't know. Might even be able to finish the whole thing. Let's do this. Everybody's looking up here. We've already had our little talk. You can discuss this later. I'm going to make this a 5-sided figure, and I'm going to make this a regular polygon. What does that mean to be a regular polygon? It looks like what? Because it's regular. A regular polygon is regular. That's the definition. Is that really what you want to say? Come on, be more specific. It looks normal. No, you think I'm going to accept that? It looks normal. There's two things that are true about a regular polygon. What's the first one? Say it, Connor. All the sides are what? Are equal. And what's the second thing? All the angles are equal to each other. That's the definition of a regular polygon, okay? So it doesn't just look regular. We can't use a word to define the word we're trying to define. Okay, enough of that. Let's do this. It's not the same thing. So what I'm going to do is I'm going to put a dot. See that dot right there in the middle? Okay, I am going to, let's see. No. All right, so there's a dot right there. I put that dot there for a reason, okay, because it's very important. So what if I did this? We'll color code this a little bit. What if I drew a line segment from that dot that's, we'll say in the middle, for lack of a better term, okay, so that little dot that's in the middle, if I drew that from there to there, that is called the radius of this. Where do we usually talk about radius?
Circle.
A circle, okay? But we can talk about a radius of a regular polygon, okay? So this is the radius. By the way, I didn't mention this. That thing that's in the, quote, middle, we don't call it the middle, we call it the center, all right? It's the center. So it's the same distance to all of these what? What are these points where they come together? It's not a corner. It's a vertex. It goes to a vertex, okay? Each one of these. If I drew another one from there to there, what's true about the distance of those two radii? Yeah, they're equal to each other. So I could keep on doing that if I wanted to, okay? They are. All right. So that's a radius. Let's do this. I'm going to erase this just to give you some room. See this angle that's formed by those two radii? Okay, we call this angle, and it's not much of a stretch, we call it the central what? Angle. All right. Where's the central angle? It's formed at the center, so the vertex of the central angle is at the center, right? And is drawn two consecutive radii. Does that make sense? Right next to each other. We good? So that's a central angle. Now, here's something that's a little different. I'm going to erase this a little bit. Oops, there we go. Let's use a different color. Here's a word I bet you have not heard before. If I go from here, now how do you think I'm drawing this? Not just straight down. Don't say straight down. Perpendicular, thank you. Perpendicular to one of the sides. So from the center, do you see it? Perpendicular to one of the sides of the polygon. Now, is there just one of these? No, I could have drawn this from there to there, perpendicular, from there to there, there to there, there to there. Agreed? So I could have done any of those sides. But this thing right here, this is a new word for you. It's called an apothem. A-P-O-T-H-E-M. All right? That's an apothem. Right with me on that? We're going to deal with that apothem here in a little bit.
I never would have guessed that.
No, it's a word, like I said, it's a word that you probably have never heard before. All right? And I think this is the only time I've ever heard of this, is in this certain situation. All right. So what we're going to do is a quick little example. And we're going to do another polygon. But this time I'm going to make it, how many did I make it? 8. Let's make this 8 sides. So what kind of polygon is it?
Octagon.
It's an octagon. And it's not just any old octagon. What do you think I'm going to make it? It's a what? regular octagon. So all the stuff we're doing today is just regular polygons. If I could grab this dumb thing, there we go. Okay, is that the name of the lesson? Yep, areas of regular polygons. Okay, watch this. What they're going to ask for is the measure of the central angle. All right, so that's what the question is. I'm not going to write it down. You can write it down. So let's find out where the central angle is. Well, here's the center right there. Luckily, this program shows me where it is. Okay, so let's draw a central angle. So it would be from where? From the center where? To a vertex. Agreed?
Yeah.
And then, is that a central angle right there? No, I need another one right there. That would be the central angle. Would it be from here to here? Because that's connecting it. Is that the central angle? Is that the central angle? No, because the central angle could be all kinds of different angles, couldn't it? So it's to a consecutive vertex, okay? So it's one radius, and then the other radius has to be to the consecutive, which means one right next to it. Make sense? So what's the central angle? It's that right there. So how do I find that central angle? Nope, don't need a protractor. Actually, let's do it from here. Watch, I'm going to try to help you out a little bit. Get us thinking. We mentioned radius, and we said, where do we normally hear radius? On a circle, okay? Now let me ask you this. Here's something that you probably already know. I don't think we've talked about it in here, but you probably already know. So what if you were from here all the way back to here? How many degrees is that? 360. You got it, okay? So this one, how many angles do we have? 1, 2, 3, 4, 5, 6, 7, 8. We got 8 angles because you got 8 sides, right? So I got 8 central angles. So altogether, from here all the way around would be 360. So how do I find just one of them? Just divide it by 8. That's it. Okay, and that is 45 degrees. So this angle right here, the central angle, is 45 degrees. What if I wanted to find, let's do this a different color. What if I wanted to find this angle and this angle? First of all, what do you think is true about those two angles? They're equal to each other, okay? Right? So that side and that side are equal, right? Remember that? We have a triangle. We got two equal sides. The opposite angles are equal. That's why they're equal to each other right there. So how would I find that? How would I find the measure of those blue angles right there? Just look at this one triangle. Forget the whole thing. Just look at this one triangle that's formed. If that's 45, what do I do? 180 what? Minus 45. And what's that? 135? So does that mean this is 135 and this is 135? No, they're both the same. So what do I do with that? I take the 135 and do what to it? Divide it by 2. And that is 67.5. So that's what this angle is right there, 67.5 degrees. Okay? Everybody with me? Yeah. So that wasn't too hard, was it? Let's do another one. This is where the apothem comes in. I got like 2-3 minutes left. So let's give it a try. I'm going to do a pentagon this time because that's what they did in the book. So let's do 5 sides. And again, it's a regular polygon. Oh, come on. There we go. This is example 2. The first one was example 1. I don't think we're going to be able to get to example 3, but here's what I want you to do. I'm not going to reteach it. I want you to look at last year's, find example 3, okay, and then watch it on YouTube, all right, because I am going to sign the homework for you. So let's do this. What's the first thing we've been putting on here? The center, right? So let's put the center right here. And I'm going to put, just because of time, I'm not going to change colors this time. From there, there's 2 radii. And now what I'm going to do, I tell you what, on this one, this is a little special. So oops, it's not what I wanted to do. Stop. Wasting time. There we go. So this time I am going to put the apothem. And we have a formula. I'll tell you the formula. I'm not even going to show you like where it came from or anything. The area of a regular polygon is 1/2 the apothem times P. P is what do you think P is of this? It's the perimeter of the polygon. A is the apothem. Okay? So this doesn't work just with a pentagon. All right, this works with any regular polygon. Okay, anytime you have a polygon that has the same sides and same angles. So this is the apothem. This is the radius. We call this S for the side. Okay, so how would I find this? How do you find the perimeter of this thing? That's a side, that's a side, that's a side. This whole thing right there is a side. How do I find the perimeter? What do I do with the S's? Add them all up. Or you just count how many sides and do what? Multiply it, okay? Everybody with that? With me on that? Okay. So what if I told you the apothem was 12.1 and I told you that the sides were 10? It's very easy. Watch. I'll do the math for you. It's 1/2 times the apothem. What's the apothem? 12.1. I don't know why they used a 0.1 there, but anyway, what's the perimeter of this thing? Is it 10? It's 10 times what? 5, which is 50. So what do you do with this? Plug it in, and it comes out to 484. Why is everybody leaving? Just because the bell rang? Does that mean anything to you?
Yeah.
No, it should be me dismissing you. So, section 7.5, and it's numbers 5 to 12 and 14 to 22. There's no B to this. Okay? There it is right there. Make sure you watch the video to watch that third example. That third example is really important.